10th Physical Science, Lesson Classification of Elements, Topic Properties of Elements and their Trends in Groups and Periods. Third one is ionization energy. The energy required to remove an electron from the outermost orbit is called ionization energy. This is a lithium atom. Inner shell contains 2 electrons and outermost shell has a 1 electron. So first electron is removed by using some energy that is called ionization energy. First ionization energy. Second electron removed by using some energy that is called second ionization energy. First 1 electron removed by using some energy that is called first ionization energy, and second electron also removed by using some energy that is called second ionization energy. Ionization energy of an element depend on nuclear charge, screening effect or shielding effect, penetration power of orbitals, stable configuration, next atomic radius. First, nuclear charge. To remove the electrons in the near shell required more ionization energy, and to remove electrons in distant cell required less ionization energy. Around the nucleus, number of cells are present. So outermost cell electrons removed easily by using less ionization energy, and it is very hard to remove the electrons from the near cells. It required more ionization energy because of nuclear charge, more effect on the near cells and not effect on the outermost cell. Between sodium and chlorine, when we observed, sodium has a atomic number 11 and chlorine atomic number 17, but here 17 protons and 17 electrons are there. So 17 protons are attracted by the nucleus. So these 17 protons and 17 electrons are same, and it is very hard to remove the electrons from the chlorine. Okay, so ionization energy is more in the chlorine atom. Next, screening effect or shielding effect means 2 types of atoms are taken here, lithium and cesium. Lithium contains 2 cells around the nucleus, first cell and second cell. So there is a less inner cells are there in the lithium, and when we see the cesium, number of inner cells are there between the nucleus and outermost cell. So more inner cells are present between nucleus and outermost cell. These inner cells works as a screens in the atom and acts as a obstruction to decrease nuclear attraction over valence electrons. This is called screening effect. Cesium has a less ionization energy. So outer shell contains electrons, so it cannot affected by the nuclear charge, so it is easy to remove the electrons from the outer cell. But inner cell contains electrons affected by the nuclear charge. Why? So it is very hard to remove the electrons from the inner cells. So between the nucleus and outer cells, inner cells are acted as a screens, so it acts as an obstruction to decrease nuclear attraction over valency electrons. Okay, cesium has a less ionization energy. And lithium has a less inner cells, it has a more ionization energy. So less number of inner cells are there between the nucleus and outermost cell in the lithium, so it has a more ionization energy. Penetration power of the orbitals. So here is the atom and KLMN main cells are there, SPDF subcells are there. So SPDF orbitals in same main cell have a different piercing power towards the nucleus. So S has a more penetration power and F has a less penetration power. So it is very easy to remove electron from F orbitals. So S orbitals are there and F orbitals are there, but S has a more penetration power than the F orbital. So it is very easy to remove electron from the F orbitals. Suppose here barium has a 4 electrons, so electron configuration 1s2 2s2, so more penetration power is there. Boron has a 5 electrons, electron configuration 1s2 2s2 2p1, so here we can see the less penetration power. So ionization energy is more for beryllium than boron. Next one, stable configuration. So oxygen and nitrogen atom taken here. Oxygen atom has 8 electrons, configuration 1s2 2s2 2p4. So here first orbital filled with pair electrons, second orbital filled with pair electrons, and p orbital first one is filled with paired, but another two ones are lonely electrons are there in separately remaining orbitals. And nitrogen atomic number 7 electron configuration 1s2 2s2 2p3. First orbital filled with paired electrons, second orbital filled with paired electrons, but 3p orbitals paired 1 1 1 unpaired electrons. So same electrons filled with unpaired electrons, but here balanced orbitals are there. But here p orbital first one is filled with paired orbitals, next two unpaired electrons. So there is a difference between these two p orbitals. First one is unbalanced. So first one is unpaired and second one electrons are there. But second p orbital same electrons are filled with orbitals. So this is called balanced orbitals. So it is easier to remove one electron from oxygen than nitrogen. So N has a stable half filled electrons. Stable half filled electrons. So stability is there for the nitrogen. Next, atomic radius. When more the atomic radius, less is the ionization energy. When less the atomic radius, more is the ionization energy. So here less atomic radius is only 2 cells are there around the nucleus. So here we can see the less atomic radius. So next, in this atom, more atomic radius is there. 1, 2, 3. 3 cells are there around the nucleus. So more atomic radius can be seen here. So when we see the group wise, fluorine has a 1681, chlorine 1251, bromine 1139, iodine 1008. So group wise, top to bottom, ionization energy decreases as we go down in a group. Okay. And when we see the period wise, lithium 520, beryllium 899, boron 900, carbon 180. So the ionization energy increases from left to right. So it is about the ionization energy.